Hi everyone, it's Coach Fred here, and at the request of a student that is in pre-calculus working on partial fraction decomposition, I'm going to go through a few different types of examples, so there's going to be probably 3 videos so that they're all short. But basically, you need to understand that if you're given a function, calculus reveals its rate of change at any frozen instant. So we're going to need to learn an algebraic technique to find a function if its rate of change is known, all right? So typically we might have this function and we might need to break it apart into smaller functions. Or, in calculus, you might be looking at finding the area under a curve. And that curve might be a polynomial. And so we're going to have to break it up into smaller functions. So partial fraction decomposition is basically breaking something into smaller fractions. Okay, so let's look at an example of how we've done it up to now. In Algebra 2 and in pre-calc, you might have taken an expression like 3 over x minus 4 minus 2 over x plus 2, and your teacher would have said to simplify it, and that would have meant to combine it. So if we combine it, we know that our denominator is going to be x minus 4 times x plus 2, and our numerator, we'd multiply this side by x plus 2, so we'd get 3 times x plus 2. And on the other side, we get minus 2. We'd multiply this side by x minus 4, so 2x minus 4. All right, so then we'd simplify. Notice I'm not saying equals, I'm simplifying. So we've got 3x plus 6 minus 2x plus 8 all over that denominator of x minus 4 times x plus 2. And then I combine like terms, and so that would give me x plus 14 all over x minus 4 times x plus 2. Okay, so we have learned how to take the sum and the difference of these rational expressions and make them a single rational expression. Now for calculus, what we're going to need to be able to do is we're going to actually have to reverse the process and go back to this. Okay, so that's what we're going to be doing. We're going to use this process to reverse it. So we're going to go from this to the broken up fractions. So we have to know when we can use this process. This process can only be used in certain cases. So if I have a polynomial divided by a polynomial, so I have a rational expression where the highest degree of the numerator is smaller than the highest degree of the denominator, then I can use this process of partial fraction decomposition that I'm going to go through now. Now, it is important to notice that there's 4 different cases, which means that we have to be really careful. To do this partial fraction decomposition, the case that you use is going to depend completely on the factors of the denominator. And there are 4 cases that we could have. We could have the denominator is a product of distinct, or meaning different linear factors. The denominator is a product of linear factors, some of which are repeated. The denominator has prime quadratic factors, or the denominator has a repeated prime quadratic factor. And that one I'm going to save for much later. But we're going to look at these first 3 cases, and this video is going to be about case number 1. Okay, so let's look at case number 1. The denominator is a product of distinct linear factors. That means different linear factors. There's no repeats. All right, so here I have this expression, x plus 13, it's rational expression, x plus 13 over x squared minus x minus 20. The first thing I need to do is I need to get my denominator as the product of linear factors, so I need to factor it. So that's going to give me x plus 13 all over, let's see, if I factor that, that's going to give me what? X minus 5 times x plus 4. Okay, now the process that we're going to use, we're going to set up an equation. Now our equation, we're going to take those 2 factors and we're going to write them as separate fractions. So we're going to have an x minus 5 and an x plus 4. So we're going to take each distinct factor and write it as its own fraction. And above that, we're going to give the numerators constants. So I'm going to call the first numerator's constant a and the second numerator's constant b. Okay. Now, we're going to use the idea of clearing fractions to help us. So at this point, I have an equation that I've created, and so I'm going to clear the fractions by multiplying everything by x minus 5 times x plus 4. I'm going to multiply every single term of the equation by that. So you can see on the left side of the equation, the x minus 5 and x plus 4 are going to cancel to 1. So I would get x plus 13. And on the right side, I would get a times x plus 4 plus b times x minus 5. All right, now I'm going to simplify that. So I'm going to distribute my a and my b. That's going to give me ax plus 4a plus bx minus 5b. All right, now this is where it gets tricky. We have to understand that that is a constant and that is a constant, and these both have a term. They're terms with x. So I have to collect the like terms on that right side. I'm going to leave that x plus 13 over here, and I'm going to rewrite this as ax plus bx. I'm going to collect the like terms plus 4a minus 5b. All right. Now, oftentimes in algebra, you guys get so hung up on trying to solve equations. But right here would be a great opportunity just to remind ourselves of what equals means. Equals means is the same as. So this is the same as this. So what we want to do is we want to get it so it kind of looks more similar. So how am I going to do that? Well, I'm going to look at this and this, okay? If I factor out an x, then I could actually write this as a plus b x, okay? And then this is just a constant for a minus 5b. And I'm actually going to put it in parentheses just so you can kind of see what I'm thinking. So we want to use synthetic division to divide. It might help you if you put a 1 in front of the minus 2x cubed plus 13x. Now let's look at that now. Minus 6. I want to divide it by x. So let's look at what's similar. What's the same as? So I'm going to switch to a highlighter so you can see it. Equal to 0. So is this in front of x and is this in front of x? To get negative 2. And that is the number that's going to go inside my box. And is this the constant? I'm going to use, we can use that idea every term set up making sure that I put a placeholder 0 if there's any term missing. Now it's in standard form, and I can clearly see that the x squared is missing. So I have to pretend that there's a 0x squared in my polynomial when I write my coefficients. 4a, because you can't skip minus terms, 5b, and that's a really important thing 13. In both long division and polynomial. So now I've got a system of equations that'll help me find a so my coefficients would be 1. These are both in standard form. 0. Me looking 13, at this, the best method for me, I thought was elimination. So I'm going to multiply the top equation by 5. Then rewrite it neatly under my equation. So 5a write my number plus 5b. So that's going to give me negative 2. 5. I'm going to add down. And now I'm going to add the equations together. When I add down, I'm going to get negative 4. 9a. Then I'm going to multiply negative 4 to negative 2. That's going to give me a positive 8. So a equals 2. I'm going to add down. All right, so if a equals 2. All right, I'm going to multiply 8 times negative 2. That's going to give me negative 16. Equals negative 1. I'm going to add down. I have my two factors. That's going to give me 3. I have my two variables, then I'm going to multiply negative 2 times 3. So now if I go back to the original, the composition would be that a is 2. So when I add down, I get 2 over x minus 5. That last spot, and if I kind of put a little line here, so that becomes this is my remainder. Negative 1 all over x. Hold on there, mama. Because now my remainder is 0, and that actually tells me something. Rational. That tells me that negative 2 all right, guys, so that is when the denominator of the polynomial. Distinct or non-repeated linear factors. It is an x video number 1, so stay tuned for video number 2. And this is one of the reasons we use synthetic division. Have a great day. Synthetic division is a really quick and easy way for me to find the zeros of a function if it's not factorable. Because if I can't factor it, I need another way to do this. So now I know that negative 2 is an x-intercept of this function. Now let's talk about what our depressed polynomial is. Our depressed polynomial would be, remember we go down a degree, so x cubed minus 4x squared plus 8x minus 3. All right. Now, that is my depressed polynomial, so I know that that times x plus 2 will give me my original polynomial, x to the 4 minus 2x cubed plus 13x minus 6. Now, this could actually be factorable or not. If it's not factorable, we're going to get into ways to actually do synthetic division again, and that's going to be in a future unit. So for now, I'm really excited because I got this 0 to be a remainder. What that tells me again is that negative 2 is a root or a 0, And guess what? X plus 2 is a factor of the polynomial. All right, let's look at another example.